Hey everybody, welcome to TCP-Talks with Jonathan Baker and Justin Broadley from the Cloud Pod. In this series, we're bringing you interviews with the best and brightest leaders and heroes from the tech and cloud industry.
Good afternoon, Jonathan. I have a fantastic guest for us today, Ravi Mayuram, CTO of Couchbase. Ravi, could you introduce yourself just a little bit?
Good afternoon, Justin. It's fantastic to be here. It's good to be on the show. Hi, Jonathan. I'm Ravi Mayuram, CTO here at Couchbase. We are a database company.
Do you consider yourself just a database company, or do you consider yourselves more of a NoSQL database company, perhaps? Or is the world of NoSQL now transitioned to just being SQL companies?
Fantastic question. We set out to build the next generation database. Sometimes you have these marketing monikers that goes along with it to say you're this category versus that category. But in general, databases were built in the 70s, the ones that we see popularly, the relational stuff. When we started to build this about 10 odd years ago, the question was, the world has moved on from where the assumptions on which we had to build the relational systems. There was no internet back then. Memory is way cheaper than what disks used to cost back then. There were no mobile anything. So that was the reality on which the relational systems, and their job was to move, it was called electronic ledger, the first versions. Their job was to move the physical ledgers to electronic. So they were all built for double entry systems in accounting, basically. From there, we have come a long way where the data itself doesn't look anything like that. We have all of these social stuff that's happening in front of us, all the interaction, all the mobile stuff happening. So the data itself has changed tremendously. So in this world where it's all cloud consumption-based cloud computing and edge-oriented consumption, what should the database really be looking like for the next 30 odd years? And so we built this database, and yes, it is NoSQL at a certain level, but it is beyond that. And our idea was to build a database that will sort of bridge people to the sort of the new economy, if you will. Otherwise, we are using tools that were built in the 70s and 80s for consumption in this world where data has completely changed, consumption has completely changed, and this is the world we need to adopt to. So at a certain level, we are NoSQL. At a certain level, we are just a database, a data platform, if you will, beyond that.
Yeah. I joke often on our show, the main show, that a true NoSQL database is not truly mature until it's built a SQL interface back to the NoSQL data.
Well said. Well said. We actually did do that here. Step back a little bit and say, when you're building a new car, you never ask the question, does it need to have wheels? Does it need to have a steering wheel? Does it need to have the gears and the pedals? It's assumed that's how you will be sitting in a car and driving. Except in software, the first thing we do is that when we build new software, we say, hey, here's a new API. Which basically tantamounts to saying, oh, my car, you're going to drive differently. You're going to breathe harder to go faster, and you're going to lean back to brake, or some new paradigm like that. And as opposed to, hit the steering wheel, turn the steering wheel this way and, hit the gas pedal to go faster. So we change the user interface first and foremost, and then everything becomes a slippery slope from then on. Just to validate your point, so we put SQL on a NoSQL database some 6 years ago. We call that Nickel or SQL++, because its evolution of SQL itself had to happen for this, a flexible data format, as we call it, which is, or no schema in some cases. That's where the NoSQL came about. Actually, I'm comfortable with the NoS part of it, which is no structure, but the query language had to be SQL because you cannot change the steering wheel, so to say. And we built the opposable thumb there, which is joins, because that's what you actually use to join. And this is, again, a good number of years ago. But then we have evolved it from there to building more and more of the SQL compatibility so that it is easy for people from the relational world to come and start using this for all the benefits of scale and performance and flexibility, schema flexibility. These are the fundamentally big problems that we have to solve in the fundamental database world.
As I was doing research for this interview with you, I was looking at the history of NoSQL, and I learned something, which was that the original term NoSQL was actually for a relational database. It was just a non-SQL interface to a relational database, and it took another almost 12 years before
Yeah.
the term was kind of usurped again for a non-structured
Correct.
database engine. It's quite kind of interesting.
Correct. And then we used to apologetically eventually say that it's not only SQL was the other, the NoSQL was interpreted that way. But the fundamental thing is that you had to change. It's like I use an analogy to describe it's easier. It's almost like a Tesla. You have to innovate underneath the hood, everything. The steering wheel, the gas pedals, the windshield wipers, and the wheels, they were just perfectly fine. Don't touch them. Where you had to make a change was, switch out the gas engine or the internal combustion engine to an electric motor and the battery versus using, gasoline and stuff like that. That's the fundamental change that we have made because this is about a different architecture which allows for different types of data and how to scale, how to geo-distribute data. These were all problems which relational systems did not have to address and solve, but they were bolted on later, so they never sort of solved them as efficiently and as elegantly they need to. Those are the problems we solved.
Yeah, that was an ops problem back then.
Yes, it's not a developer problem. Nowadays, DevOps is one model, so the moment you develop, it's immediately a problem. It's no longer somebody else's problem. You just have to scale. The fundamental shift here is this, that earlier, those systems that you correctly pointed out, they were all built for enterprises, internally focused. You basically would have trained users, you will, use those applications built on top of those. Nowadays, the systems we build are directly to consumer. That's the movement. It's no longer, just to give you an example, there are no more travel agents. Earlier, we would go to a travel agent who will make the reservations for you and stuff like that. Nowadays, it's you and your two thumbs. So those systems which were earlier for specialized people to interface with are now direct to the consumer. And that's a humongous shift in both in user interfaces, usability, as well as performance and scale. Because now, earlier, maybe you had to interact with 100,000 travel agents, but right now you have to interface with billions of users. In the travel industry, they have a ratio. It's called look to book ratio. So earlier, the look to book ratio used to be 100 to 1. If you looked at something 100 times, you would actually get a booking out of it. That's what the system was built for. Nowadays, it's 10,000 to 1. A lot more people are looking before actually a book happens. So this is the foundational shift for which these newer systems and databases, which can scale and which can perform and which can handle those levels of concurrency of millions of users using the system simultaneously. That's what these systems are built for.
So Couchbase is one of a number of NoSQL databases. What do you think sets it apart from other competitors in the market?
Yeah, one of the key things is what you already pointed out. All these NoSQL databases took that literally to say you don't need SQL, whereas we said that it sort of requires SQL. So at a certain level, what we are is a database which has sort of evolved. Just to give you another analogy as an example is that, phones evolved to a point where it became smartphones, right? Which is now a smartphone. I think the last thing it does well is a phone call. It does everything else better, my experience. Sometimes I don't even get notifications for certain phone calls, but I get the messages faster. So it's like that. It's an amalgamation of 40 devices into one. Similarly, the modern database has to do more than what the old database did, the legacy ones, because they were all built at a certain point in time, and we have built multitude of systems after that. Now it's time to sort of consolidate those into one. So in that regard, Couchbase is different because it's not just something that did the classic database workload alone. It brings 5 systems together, if you will. It brings a cache and a key value store. It's a document store. It's a relational document store. It's a search system. And finally, it's an analytical system. So some people call it translytical system or hybrid transaction analytical system. Earlier in the good old days, we actually had a separate OLAP system and OLTP system kind of stuff, because if you ran an analytical query, it will completely stop the operational side of the database. And so you had to separate them. Now, with the modern architecture, so you can fuse them back together because of all the networking and other advancements that we have in the middle of the innovation here. And so we brought them back together. So these are the 5 systems in one place, which is very unique from the standpoint of Couchbase. And the second thing is, we really do well in a geo-distributed manner. One click of a button and your data is available across availability zones, and you can do what is called as active-active deployments, which means you can run it on, let's say, US and Europe concurrently, where your people don't have to come across the pond to get the data from one side. They can operate on the other side, and things will reconcile themselves. There's the area of replication, which is another of our major advancement. But finally, it's about performance at scale. You can do all this stuff, but if it doesn't have the snappy performance that you need, otherwise, you know how fickle consumers can be. They move on to the next site if you don't have. And there are studies on this one, how millisecond responses, delays in responses, you lose dollars, because the e-commerce industry has done that study. So these are the kind of places where we get used for the performance and scale, for geo distribution, and for the ability to do multiple things on the, we call it optionality, as in like you don't have to just put this one in, and you don't have to keep introducing newer software systems. For search, I'm going to write another connector and move the data. Oh, for analytics, I'm going to put another system and move the data. It then translates to cost, number one. And second is security, because now you have to manage 5 systems, and all the threat surface area and all those areas, all those products, you have to learn and secure them and all that stuff. So it's about consolidating those and offering a performance at scale at a cost which is much cheaper than if you were to operate all these 5 systems independently.
Yeah, this is one of the big concepts that was talked very heavily in some of the Spanner, white papers and some of the things they did when they first released Spanner. How do you see Couchbase sort of comparing to the global database concept that Google talks about in their Spanner white paper?
Yeah, I think we have a slightly different take, though we understand the point of geo distribution. We totally understand, but globally consistent database is very few companies would actually sort of need that in one sense. Our general philosophy is that the performance is the biggest problem there, because imagine light on glass from East Coast to West Coast is 65 milliseconds. And if you were to say that all my transactions is going to have that sort of a boundary, your global consistency is basically going to be that slow. You can do one transaction every 65 milliseconds. That's if your wire speed, which you won't be mostly. So it's going to be slower than that. So our general philosophy is to do the transactions locally within a data center or availability zone and replicate, and so that the data is available on the other side. And we are memory to memory with network in the middle. So data is available very close to the light on glass speed, and now you can do high availability stuff on the other side, active configuration. So that's how our philosophy sort of differs, but we offer a full distributed transaction capability across, because many of our customers run hundreds of nodes for scaling. So we have full SQL transaction, and the beauty here is that unlike relational systems, which make you sort of choose the whole asset concept for everything you do, in Couchbase you sort of laid bind to that, by which I mean you can do a lookup operation, a key value operation in microseconds, and then you can do a transaction in the middle of all of these lookups. Let's say you're looking for user profiles and suddenly you want to do a transaction of buying. You pay the cost of a transactions only when you're sort of doing that sort of an operation. Otherwise, you don't pay it. So it becomes both faster and cheaper. These are the two main issues with sort of relational systems, because they make you pay the price of a transaction even when you're just simply updating somebody's profile picture. You don't really need the transactional integrity for that. Where you need the transactional integrity is when you're actually doing a commercial transaction or buying and selling or account book balancing and stuff like that. That you can lay bind to that. What I mean by that is you only pay the cost of a transaction only in that operation, not when you're doing a profile lookup or add one more social channel to your profile. Those kinds of operations. So this is the innovation that we have really brought to this equation.
Yeah, as you were talking through that, it reminded me a lot of what we're seeing in the cloud space around the move to edge computing, and really you see Amazon and we see Microsoft like really pushing hard into edge. You're seeing a lot of partnerships with Verizon's, the AT&Ts of the world, defining their own cell phone networks. How do you see edge being part of what you just talked about?
These days I say that edge has become a core part of the technology stack, so to say. It's core part of the enterprise architecture. to the extent that people who had sort of edge-based solutions, I'll use one example here of Pepsi for their sort of delivery system. They already had a mobile-enabled workforce. They had their own device, and which was all based on a 3G network. Now that has gotten obsolete. So they have modernized that into the 5G world using Couchbase. And if you really look at it, you don't realize it, even though they had, their delivery truck, their people, they actually do commerce from that device to the extent that they give quotes to their they go to the different, so what they do is that the workforce, their field people, they go to retailers and give them the supplies. This is for Frito-Lays and their other called packaged goods, and so they deliver that. They take the orders of both inventory and order, and they do all that order management stuff. So critical commerce happens from their devices. Now those devices, if you look at them, what they're using now, unfortunately they look a little old because they have these buttons, and each button, what you have to press to do that, what action is it's going to take. It looks like little from Star Trek or Star Wars movies of the past. Now they have sort of modernized this on sort of the modern tablets and Gorilla Glass based devices. So it looks like just carrying your smartphone, and it does all the stuff. Now, why I'm saying that is that this was the modernization many enterprises go through, because they know that the interaction with their customers happens at the edge, and so the data needs to find its way to the edge. There are two edges that is sort of emerging. One is the network edge, which is what more of the Amazons and others are talking about. Then there is a true edge, which is where people are actually interfacing. There is, of course, variations to that, which is industrial edge is there, and then there is a human device edge and sensor-based edge, if you will. So we built a mobile database which is available on these devices, and we have a sync capability, so the data is instantaneously available to you on the device. So we say we are a database that's built for failures. Your rack can fail, we have replicas, so our system will still run. Your network switch can fail, you'll still run. Your availability zone can fail, will still run. Your cell tower can fail, the application will be on. So our idea here is to make sure that the data is available wherever you're interacting with it, and so that way your application is always on. And whenever the network is restored, connectivity is restored or available, the data is synced back, and you're back in sort of connected in the connected world. So this is how we see that the edge has got a lot more compute than what you're going to have in the cloud. And so and what is all that compute going to do unless it has data to compute on? So move the data closer to where the engagement is, and then so that way the applications are responsive and always available.
It's funny, isn't it? Because edge very much used to be a CDN.
Correct.
And then it became, well, it's the ISP and the local POPs, because that's where Netflix dropped all their servers, and now that became an edge. Now we have the mobile edge, and now I think even with compute in things like Google Homes and smart devices at home, that's become an additional edge.
It's fantastic. Exactly the point that you're making is very critical there. Yes, that the edge is like, it's basically what is happening is that decentralization is what's happening from one single place like a cloud or your data center or your mainframe. It's getting distributed to, and that's what we keep defining as edge based on the context.
So as a consumer, is it simply latency? What would you say the primary advantages were for bringing data closer to the consumer?
Yes, absolutely. It's the last mile problem. It's the latency of the data being available there. Let's say, what has happened is that because of all this people consuming from devices and stuff like that, we have a lot of mobile applications, but only the application logic, the UI and the logic is sitting on the device. The data is still getting fetched from the cloud because it's sitting behind 3 firewalls, because we understand data is very important. So you would see, the circle of death in front of you, and we always end up blaming the network for it. But network is not truly the problem. The problem is that the data has to go through 5 firewalls, the API, the REST API that you're calling, and is trying to fetch the data from, multiple hops up across, many geos, and finding it and fetching it back. It is not there locally for it to do. So if you move the data closer to the edge, that's why you need databases for. So it is basically available to you to operate on. And then sort of asynchronously move it back and forth. Then you really don't care where we call it, location unaware data. Like you should not know whether it's sitting in the cloud or it's sitting in your local device. Not your problem. We'll solve it for you. So that way, you are always working on, your application is always on, and then we synchronize the data in the back. So it's about the no matter how fast you are sort of all the way to the edge of the network is, the last hop from between your device and the edge, it's still in seconds, it's not in microseconds. And that's the problem you need to solve, because you have sufficient compute in your smartphone for it to do a lot more if the data is available locally.
Latency is definitely an important thing, especially with the money and the economy around things like mobile gaming.
Right.
I guess the other important thing for me, I've worked in healthcare in that industry for a long time,
Yes.
and reliability and the unavailability of the network at critical times is important.
Absolutely.
Could you talk a little bit about how Couchbase has helped finance and healthcare applications where
Sure.
lack of connectivity is critical?
Yes, healthcare definitely is a fantastic example. Let me just give you one that'll give you your imagination will run wild after that. Insulin tracking. People have all these devices these days which can monitor your insulin, and then can even insulin pumps are there which then inject insulin into you. These are devices that you want working no matter where you are. Network availability, Wi-Fi availability is is the last thing in your mind at this point. So these devices use something use Couchbase Lite, as we call it, which is in there. So it does all the insulin tracking for you, and then based on the sort of ranges in which it is, if it is outside, then the insulin is sort of injected, and all this data is stored, and then eventually it is synced. So your doctor can eventually see this and take action and tell you, yes, under these circumstances, your insulin is low, under these circumstances high, on these dates and all that. So you can track, you can have a decent conversation with the doctor, and maybe you're tracking somewhere and there is no network availability or cell tower availability, for days. And when you come back, but all the data is still available. So like this, there are a lot of use cases of this nature where in the healthcare industry, like operating rooms, we are in the devices which are in the operating rooms, and they send this data eventually, because when you're inside in the operating theaters and stuff like that, they try to keep those zones free of radiations and networks and all that stuff. So those areas you will not find connectivity. But when these devices come out of that, or when they are not operating, then they can basically sync to a local device, which then can move the data to the cloud. So now we can see, and the next step, of course, is that you can do some remote stuff on top of it. But we are sitting in operating theaters, we are in insulin tracking, and those sort of areas where healthcare is one fantastic area where we see sort of these sort of use cases. And the flip side of it is that it is not just, don't think of it as just the edge, because that data is meaningless if it is just sitting in the edge, or if you just get it in isolation. When that data comes to the server, that's when the real magic happens, where you can, there are examples of people doing concussion detection using this. Just doing your eyeball movement, they can figure out whether you have had a concussion or not, which is done on the device. And that the data is synced back to the cloud. Now you can do correlational stuff. Which other sports or which other PTSD scenarios is applicable to here? This work actually happens based on the data. So the real magic is when data actually comes, when you can actually correlate, find patterns, project, and you can actually now take corrective actions, or in the case of IoT sort of scenarios, where you can actually do maintenance if some device is always failing, or you can predict things, advance of things actually happening. So in healthcare, we have those sort of scenarios which are very gratifying when you build a platform and you see it getting applied like this. It's good to see that you're actually helping.
So this is a really interesting idea and concept, and I love the use case that you just described. you have your new Couchbase Capella service. How does it help you do this? Because one of the complexities of Edge is
Yes.
how do I decide what goes in the Edge and which part of the Edge, and how do I move that data between those things? And so your Capella service seems to solve some of those problems. I'd love to hear more about that.
Yeah, I think the fundamental thing it really solves is, all this, it's a service that's running in the cloud. And we take care of all the management, administration, all those, the back room of it from the standpoint of running it as a service. And then we expose to you both the controls and the APIs through which you can actually manage and move the data. And in that, we have ability to tell you, we have a very fine-grained security model which allows you to specify what data should actually be sent to the edge and what should not be. So there is privacy, there is security, and then not just what is sitting on the cloud. We have to watch for when the data is in transit, that should be encrypted, and when the data is on the device, that should be further sort of secure, to the extent that if someone says I've lost the device, we have ways to sort of wipe out that whole thing, right? So that those are security measures which enterprises ask. And there are places where people say that, yeah, sure, this device is sort of inoperable for us, but that's only because the screen broke. Now, but the rest of the data is very precious to us. So you can do stuff like on-disk replicas. So that way you can, insert little micro SD cards into it and then take the backup of it. And then now you can throw away the device. We can kill that thing, and then now you have the full replica. You just have to, because these are field, people are sitting someplace. They are not going to come to your regional offices or headquarters to get this stuff serviced and replaced. All you have to do is ship them a new device and say, okay, do this and insert that thing, and the device is back on. To your point, managing edge and devices is not an easy thing. And so you have to solve a lot of problems so it becomes easier, because thousands and hundreds of thousands of devices. It's not, one or two, or it's not centralized. So there are a lot of management, administration, deployment, configuration problems that you have to solve up front. So it becomes easier for you to sort of, the life cycle of managing that becomes easier.
Is that why you offer Capella as a managed service rather than something that you can buy off the shelf and run yourself? Was it a customer ask because of complexity, or do you just think it's a better business model that way?
I think it's basically, things have become very sophisticated and very complex these days. So this is about reducing the developer friction. If the developer has to set up all these things and manage and then start to develop, it's not going to happen. Where is the desktop, or where is that server in which I'm going to install all these things? It becomes so. We offer this, and people can graduate to a point. Some of our enterprises run some of these things in their own private data centers too. So we offer both those things, and then everything is manageable from a single plane. But the Capella, or database as a service, is the sort of a mechanism through which we reduce the friction and make it easy for people to. And once you get really sophisticated and your deployment is big, then at that point you can make a call. What makes sense? Where should it run? Some of it should be Capella, some of it could be somewhere else. You are in control at the end of the day. That's what we want to enable, as opposed to you feeling logged in. And at every stage, we make sure that there is no vendor lock-in, including the data format, right? We are JSON. So as long as it is JSON, you can take it anywhere and go. So that's the biggest thing. Otherwise, you're vendor logged in. The moment the database says, specify a schema for me, please, write for yourself vendor lock-in. In our case, it's JSON. And then we late bind to schema. That's our beauty. So from there, we liberate you to a point of, where you want to deploy, it's totally in your control. We will make it everything easy and simple for you, so that you graduate to a point where if you have the wherewithal and the resource to sort of run some of these things in your data centers, be our guest.
Yeah, so you're talking about the data layer, which is super important in any of these edge conversations. Do you see, and this kind of goes back to something we talk about in the Cloud Pod a lot, is the SDK for the dev side of like the web, the app tier, and being able to do the same type of thing that Capella is bringing you to on the data layer. Do you see someone providing that at the software layer and the SDKs, and someone that maybe partners with Couchbase to do that?
Yes, we will work with because as you correctly point out on the application building tier, it's a landscape of its own, and we work with at the end of the day databases. The moment you have more and more of the integrations, that's when you sort of becomes easier. So we do work with multitudes of vendors, and we'll be sort of releasing even more with the modern day the React stack or the next JavaScript stack. We are going to be in all of those things, and that simplifies with something like Capella running there. With our REST APIs that we have, then it becomes easier to integrate with all these things, and with cloud providers and their services in these tier. Those are the two sort of angles, not just the dev tools side, but also the cloud provider services side, so that it becomes easy. We have to fit into the ecosystem. As you know, this is not an island. We cannot stand separately. We fit into the cloud service provider ecosystem as well as the developer ecosystem.
Got it. So if I'm looking coming into Couchbase Capella, one of the concerns I would probably have immediately is data extraction from the cloud. It's the most expensive thing you can do. So in the case of Capella, is this something that you're actually running on all three cloud providers, or something in your roadmap to do, or is this really, it's on AWS today, it's where it's going to be for a while? How do I think about that if I'm in the multi-cloud space and I'm worried about those data extract costs?
No, great question. This is the crux of the matter in one sense, the data extraction cost. Because data movement and data gravity is the fundamental principle, right, in one sense, on which this whole argument comes down to. We are available on all three clouds. So what you are is that I always say we are deployment agnostic. You can run us bare metal. You can run us in your data centers. You can run us on Kubernetes. You can run us on containers. You can run us on the Kubernetes service of each of the three cloud providers, right? So that means you have the control of how you want to deploy this and run this thing. And of course, if it runs on the three cloud providers, we manage, administer, deploy, patch, upgrade, all that stuff. So you get the benefit of all of that stuff. But now, the second question that you ask is in terms of sort of movement. Look, the network egress cost of whatever the cloud providers have is what they have. We just can't, because that's the infrastructure. But with Couchbase, what you get is tremendous cost savings, because you don't have to multiply or keep replicating the data. Once to a let's say if it's in a relational system, people typically end up moving it at least 4 or 5 times. First time is to a cache, because otherwise it doesn't scale and perform. Then you move it to a search system because you want, a schema-free way of tokenized way of looking at things. Then you move it to an analytical sort of a system, an operational analytical kind of a system, or you can move it to a queuing system. So with our architecture, you are not replicating the data so many times. And that right there is the cost savings. And the way our fundamental architecture is that it gives you, because of consolidation, you write the data only once, as in like you wrote your first, let's say, order with some description and some comments of who purchased the order. After that, you can do all this. You can search on it, you can query on it, you can do a transaction on it, you can do your analytical, how many people bought this thing, week over week for the last 5 years. You can do all that on that data without moving the data. So that's where the cost savings of Couchbase comes from. And now we are, you can set up a replication across clouds. And now you're sort of cloud service provider agnostic. And your application is just coded the data layer to the abstraction that you built over there. Beyond that, you don't have to worry about each of the cloud service providers' idiosyncrasies of security and egress and all that stuff. It is hidden from you. Yes, the cost is also less, but it doesn't go away.
We really covered quite a few things here, getting a little bit of history of Couchbase and talking about, your play in Edge, which I think is super interesting. And, we're really keeping a close eye on the Edge computing space over the next several years.
Right.
Maybe you could give us one last good use case that you think is really interesting to you, your favorite one, perhaps. Every CTO's got their favorite. And then, that'd be interesting to hear.
No, I don't have one favorite use case, but let me give you an example of how Couchbase touches you on your daily life. This is sort of my Cume use case, perhaps. Justin, where are you located?
I'm in the San Francisco Bay Area.
You're in the Bay Area, so am I, let's say. But Jonathan, where are you?
I'm about a mile away from Justin in the Bay Area. But for the purpose of the conversation, let's say I'm living in England.
Your accent is the reason why I was hoping that you would say somewhere far. But let's say today you decide to travel to London and you want to make a flight reservation and you want to make a hotel reservation, and then finally you land in London, and then you take Uber and then you pay using your credit card for all these things. In each of these things, you're touching Couchbase. You cannot travel from here to London without touching Couchbase. How? When you're basically making the airline reservation, some of the global, they are called GDS, Amadeus, and the equivalent ones in the US and stuff like that, they run on Couchbase. So when you're looking for flight information, it has to show up in microseconds. And so that actually happens on Couchbase. Now let's say you book and then you take a flight, something like Netted or something, that system, their reservation system, as well as some of the crew management systems and stuff like that runs on Couchbase. And then let's say you land there and you sort of book a hotel, Marriott or any of these, their reservation system runs on Couchbase. And finally, when you actually pay your cab using a credit card from your mobile phone, the mobile digital wallet enablement of your credit card happens on Couchbase. Big three credit reporting agencies use it. So before your transactions goes through, they validate. That's what they do. Is they look up your profile and they update the credit score every time a transaction happens. That happens on Couchbase. So pretty much, if you want to move out of your house and do something in the travel, I'm just taking a travel example. It happens on Couchbase. There are fantastic examples in sort of financial industry, in healthcare, in gaming, in digital media. If you're streaming anything, there's a good chance that your profile is managed in Couchbase. And this is the digital transformation. These are the areas where people have moved to the next generation of direct to consumer interactions, and those require the scale and performance that Couchbase provides.
Fantastic. Well, if you want to learn more about all of this, check out Couchbase.com, as well as there is a free trial I see for the Couchbase Capella service if you'd like to go out there and experiment. I'd like to thank you, Ravi, for coming and joining. It's been great. I learned a lot, as I'm sure Jonathan did as well. And so thank you very much for coming.
Lovely. Thank you so much, Justin and Jonathan, for this opportunity. It was fantastic talking to both of you. Both of you are very knowledgeable in the data area. It's always fun, having these conversations. So thank you.
Thank you very much.
Awesome. Love to have you on again in the future.
Visit thecloudpod.net to subscribe to the show, join our Slack channel, or sign up for our weekly newsletter. You can also find information on reaching our audience through a CloudPod sponsorship opportunity. A big thank you to today's guest, and thank you for listening.